Hi, everyone. How many of you have heard of Presto? Good. Surprising. So my name is Itamar. We are going to talk today about executing SQL queries on Kafka. And we'll be doing that using a product that's called Presto. I'll explain all about it. It might be a bit different than what you used to hear about in this user group, in this meetup, but hopefully it will be interesting enough. My name is Itamar. I'm the CTO and founder of a company called BigData Boutique. We are representing a couple of big data vendors here in Israel. One of them is Elastic, one of them is also Starburst, which are behind Presto, which is the product that I will be talking about today, all of which are open source. But we do integrations, we do projects, we do consulting and support around those technologies. And we do quite a lot we build quite a lot of data lakes, data warehouses, and those buzzwords, but we do it and we help companies succeed with managing their data and their infrastructure and software accessing that data. Presto is, for those of you who haven't heard of the name before, Presto is an open source product that was built by Facebook quite a few years ago. I think it's about 6 or 7 years now. They had some issues, some performance issues running SQL queries on HDFS, right? So on big data, maybe stored properly, but they had some issues running interactive SQLs or interactive queries on top of that data. They tried using Hive. Hive wasn't good enough, so they went and built Presto, which is an execution engine, very similar to Hive, which is basically what is done to be a replacement of, and also those of you who know Spark. So it is more of an execution engine rather than a database on its own. It is not a database. It is a computation engine, which is also something that we know by the acronyms of MPP, right? So massively parallel processing. You give it your data, or you put it somewhere close to your data, and it is able to just execute queries very efficiently on top of that data. With Presto, queries are very, very cost efficient. So you don't have to have huge clusters to be able to run timely queries. You just can execute your queries, and they will return in an interactive manner. Obviously, a lot of work has to go to make it happen. So partitioning and all of those things, but it works. If you do it correctly, it works. And this is why Presto really is really something that people start implementing and integrating in their systems lately. There is an enterprise version. It's supported by a company that's called Presto, which is basically a company that was established by Facebook veterans. The people who built Presto in Facebook basically went in and established their own company. So just to give you an idea what Presto is. So Presto it was designed initially to query data, cold data, on cold storage, which is HDFS, S3, and such protocols and storage systems. And it is where it really excels. So most people who use Presto to query cold data, execute SQL queries on cold data, mostly on HDFS and S3. But Presto on its own, it's a computation engine. It doesn't really tie into any underlying system. And this is why it is also able to query a lot of other databases or data sources, or however you will. So for example, obviously, it is able to delegate some SQL statements, some SQL queries to SQL databases, right? So you can put SQL databases and put Presto on top of that, and it will be able to execute SQL queries on SQL databases. No surprise here. But it is also able to query NoSQL databases, right? So databases, data stores that are not SQL by nature. So Cassandra, Redis, MongoDB, recently also Elasticsearch joined that list. So databases or data stores that are not SQL by nature, they are not relational, and maybe they don't even understand SQL as a language, as a query language, they are still, you can still run Presto on top of that, and those queries are going to run on top of that data. Maybe the most surprising bit was the addition of Kafka as a data source. So Kafka is a queue system, or to be rather more exact, a commit log that you can store data in and query or go through the data. And it is basically something that you can think of as a vertical, right? So messages come in, and then you just can read them and do things on top of them. What Presto is able to do, and we'll talk about this in just a minute, it can basically take that vertical thing and make it horizontal. So each message is going to be a row, all right, in a database, and we'll talk about this in just a few minutes. And Presto is able to do all of that using what we call connectors. So Presto comes bundled with quite a few connectors, and those connectors, each connector can connect you to some data store. Each data store has its own, obviously, capabilities and abilities. And those connectors are what basically are translating the SQL or the queries that you are going to run and pushing them down the stream into the underlying storages. Presto does behave like a database in the respect that it exposes a JDBC protocol that you can query from everywhere. So you can query from using Redash or Superset. How many of you have heard of Redash? Amazing product.
Really?
Israeli guy, Arik, amazing product. You should definitely go and check it out. Superset is pretty much like Redash, but under the Apache umbrella. So you can use those sort of IDEs or dashboarding systems on top of Presto. You can use commercial ones, so Tableau, Power BI, all of those products, they also speak JDBC, so no reason why you cannot do that. You can use notebooks, like Jupyter notebooks, those kind of mechanisms to query data stores, query execution engines as well. So you can use Jupyter to query Presto as well. And obviously, IDEs like DataGrip, MySQL Workbench, every software system that is able to speak JDBC, you can use to query Presto. And this is where Presto becomes a very central point, really a focal point where you can query any sort of data from pretty much everywhere. And the good thing about Presto is that all of those data sources can be joined together in a single SQL statement. So each of those data sources is going to be exposed to you as a catalog or as a database that you can query. And if you have multiple databases defined in your Presto deployment, you can basically just execute a single query and do joins across data sources, and the entire computation is going to be basically done and executed in Presto. And this is the beauty of Presto. Presto is being used worldwide. It has a very, very strong adoption curve. It's obviously being used by Facebook probably the most because Facebook put so much effort in building it. I think this is like data that I took from the net, and Facebook, back then at least, about a year ago, said they have thousands of nodes in multiple clusters, Presto clusters obviously, running on petabytes, hundreds of petabytes of data, and have many concurrent queries basically being executed by their analysts. But also, if you build that thing correctly, you can also use Presto to support queries coming from your application. So Facebook, Netflix, Twitter, Uber, so many such companies, and also other companies which are maybe smaller but have demanding needs as well. They also use it and use it very successfully, and Presto really shines, and especially lately. So the architecture of Presto really resembles what you probably know from other systems, like for example Spark. We have a single coordinator. There is some work to put more coordinators within a single Presto cluster, but currently a single coordinator which accepts the query through the JDBC driver, the CLI of Presto, and takes that query, analyzes it, creates a query plan, and then executes that plan using the workers. The graph here shows HDFS, but obviously you can have pretty much any data source that Presto supports and have the workers talk to it. So accessing Presto, like I said, to execute queries, you can use the JDBC connector, the JDBC driver, or use the CLI directly. And because you have the JDBC driver, you can pretty much access Presto from everywhere. And there is also a very nice UI to Presto that shows you what's going on now, and we'll see that in action. But basically, when you run real workloads on Presto, you'll see something like that, right? How many data you are reading, you are querying on, how many concurrent queries, how many users, how many failures, how much data in gigabytes or terabytes you're reading, and so on and so forth. So getting to the Kafka connector. Again, like I said, in Kafka, it is a commit log, or rather maybe a queue system that has messages coming in one after another, and this is basically what it is. You can go back and forth on a Kafka queue or a Kafka topic to just read that data, which is cool. What Presto is able to do with the connector, it can take that queue and make it horizontal and make every row, every message like a row. We'll talk about how you understand what fields you have in that message in just a second. And then you basically get to a point where each topic is being represented as a table to Presto. And then each table has columns which you define based on your schema. And then when you query, you basically query a table and rows with columns just like you would do for SQL. So decoding a message, when you have a message, that message can be just bytes, right? But that you will usually have some sort of a schema. So out of the box, Presto and the Kafka connector that Presto comes with supports JSON, Avro, and also CSV and row decoders, meaning if your data in Kafka is using one of those formats, so it's either CSV, JSON, Avro, with the schema for each message, not the schemaless Avro, or it's just raw data, which is basically just a primitive, which might be not something you would do. Then Presto, using the Kafka connector, can just transform that natively into a table, right? If it uses something else and you need your own serde, this is something that is quite easy to do, but it's not something that's very easy to do out of the box, right? You cannot just install and configure. You would have to do a bit more work, but out of the box, JSON, CSV, and Avro are fully supported. So just going back 2 steps. Presto, the use cases for Presto, like I said, is querying mostly cold data. So you have HDFS, you have petabytes or maybe terabytes of data, and you want to execute that very fast. So SQL on anything, that's the term that they give it in Presto, and you can use Presto to query cold data and also other data sources and even join them together. You would usually use that for cost-effective querying, and if you want that more interactive, you'd probably add a bit more hardware, but then you can also put analysts on top of that and make queries on cold data very efficient. For the Kafka use case, as it turns out, Presto is also very efficient or very easy to use for ETL processes. You can basically, if you build your thing right, you can take data from Kafka and you just use an ETL within Kafka, right, for another topic, or maybe to cold storage. So you can take messages in Kafka, in JSON format, let's say, and then transform them into Parquet format files on HDFS. And you can all do that with just a simple insert into, select from in SQL using Presto, which is kind of nice and kind of neat. But obviously, you can use that for querying Kafka. If you have Kafka data coming in real time, you can just query Kafka and get results, and then maybe, I'm not sure whether this meetup likes the concept of Lambda architecture, but this is a nice way of implementing that. You can submit a single query to join basically results both on real-time data on Kafka and from cold storage, which is pretty much what Lambda architecture is all about. And also, obviously, allow your analysts to just query data that is in Kafka. And again, I'm assuming live data, but obviously Kafka can be used with long retention periods. So we're a bit short on time, so I'll just skip through that very quickly. Presto SQL is just ANSI SQL, it's just standard SQL, but it has a lot of additions like windowing functions, aggregate functions, geospatial queries. So you can actually use geospatial operators on WKT shapes if you have them defined in your data. There is some other enhancements like Lambda functions within your SQL queries, using JSON operators to extract data from JSON columns, if you will, or just your data. Other nonsense like, I don't know, retrieving back colors or extracting URL parts and doing other extractions and maybe enrichments kind of operators, which is kind of cool. How much time do I have left? 5 minutes. So I'll have a quick demo, and then I have a gotcha slide, which I would really want to show you guys. So this is the Presto UI, like you've seen it. This is a more recent version of it. Currently, my cluster is idle. I'm running it locally on my laptop. And then you can see, but I also have Kafka running. I can open Kafka Manager and show that to you. But I also have, OK, this is better. And I also have Data Grip, which is just a SQL client, SQL IDE that I can now execute to run on Kafka. This is a bit small over here, but you can see I have many connections to many databases, or just 3. And my Presto local database, if you can see it, it exposes several databases and several schemas, and each of it is different. So one of them is Kafka. And you can see that in Kafka, I have a TPCH schema, which is just demo data, and I have many tables in it. And then I have other databases available to me from within that database definition, and each of them is a different connector being used from my Presto cluster. So I can have just HDFS and S3 and all of those. So from within Kafka, from the Kafka databases, Presto sees it, I can just execute queries. So I'm telling it to use the Kafka, database, then the TPCH schema, show tables will return the tables that I have available to me, basically what you see here. I can just use standard SQL on that. So describe customer. Customer is just a topic in Kafka. But as you can see here, I can actually see the records, the columns within it as properties. There is some internal fields which describe the message key and which partition it came from, etc. And then I can just execute standard SQL statements. So select star, which return data, do aggregate functions. And here you can see I'm also using some JSON operators. So I'm accessing a field that's called message, which is the raw JSON message from the topic. And what I'm doing here, I'm basically extracting a scalar and then summing it up. I also have that specific field as its own field already extracted by Presto, so I can actually do this directly on that field. And I can do group by market segment, etc., etc. So I have the link for the tutorial you can follow that will show you just that. Okay, so the playground where you can actually run this as Docker Compose, you have that here in this Git, and you can follow a Presto official tutorial around that in this link here. And the idea is basically that you can take any data and transform it into a table using Presto in that respect. But I did do a hack here that I couldn't show you because we are a bit short in time. But basically, I had to tell Presto how to translate the JSON into what is the schema behind the JSON, right? So if it was Avro, it was already defined within the message. But for a JSON document, I had to actually put a description document that translated the JSON into a schema. So it's no big deal. You'll have that in the link in the tutorial, but it's something you have to do for JSONs. And also there's more gotchas. So for example, if you're executing queries on live topics, and that live topic, by live topic I mean new data is being added and maybe old data is being TTL'd, so removed by Kafka, you should probably expect results to change between queries. And also, if you're doing self-join on join on the same table, that could obviously also lead to some unexpected results, right? So because a row can be there at the first stage of the query, but not there at the second stage, so take that into account. And if you're joining across connectors, taking under consideration that some connectors are going to be slower than others. So for example, the SQL connectors, the connectors that are going to execute queries against old or good old SQL server, MySQL, all of those connectors are single-threaded, so it's going to run a bit slower. It's not like connectors that are against S3 or HDFS and Kafka that can also run multi-threaded. So let's have 2 minutes of questions, and if you have any questions, I'll be happy to take them. And you can freely reach me out on Twitter or whatever. Yeah.
Just repeat the question.
Yeah.
You are doing a joins. Can you index the sources after you put the information, the data?
Index where?
Index on the Presto when to accelerate the joins.
So Presto doesn't have any indexing whatsoever. It's all ad hoc. There are some concepts where you can have a very heavy query on Presto. So the question was, can you have indexes? Does Presto have indexes? Can you use them to speed up things? Presto doesn't have any concept of indexes. You can issue a long-running query, and take the results that it returned and put them in a temporary table somewhere. So you can put them in HDFS, you can put them in SQL, there is a memory connector that you can put temporary tables in. So there are ways of creating materialized views, if you will.
In the last session, you talked about windowing.
Mm-hmm.
Take a part of window. Take a part of the time.
Mm-hmm.
Watch the stream.
Mm-hmm.
How do you do it in Presto?
There is, I think I put the link for that. There is, I didn't. So in the documentation, go and look for windowing functions, windowing operators. It's a long document, and you have all the possibilities there. It's the over operator. You can basically create a...
Like in a regular SQL
yeah.
windowing function.
Yes, I think it has some unique enhancements around that, but yes, you have over time. Yeah. Yeah.
You have compared Spark with this, so can you elaborate a little bit about some major differences? And
yes.
when should I prefer, when I want to pick up my new technology? When you think it will be better, from your experience, to choose Spark? And when will it be better to choose this?
So the question is, when would you pick Spark and when would you pick Presto on over Spark? So Spark is kind of a de facto standard for computational jobs. The design behind Spark is offline. So you submit a job, it will return sometime. And Hive is basically built in a way on using Spark on top of Spark in some way, right? It also produces MapReduce jobs or RDDs or data frames. And Presto it was built for faster execution. By default, Presto has some concept of killing a query if it runs for too long. So it wasn't designed for offline jobs, offline batches. It was designed for real-time or interactive queries. So this is probably the most major difference. And the reason why it was designed behind that is because the algorithms underneath it are designed for executing the query properly, doing push downs as much as possible, using splits correctly. So a lot of logic behind how can we run queries faster and closer to the data.
Spark also have some Spark streaming, so streaming also supported by Spark. In this case, you have the receivers and you have other internal support for more faster queries.
So it's not faster queries. Spark streaming is just doing the computation on smaller batches. Yes. Presto is not a streaming technology. It supports windowing functions, but it's not streaming. It's more comparable to Spark rather than Spark streaming.
Event-based or
It's not a database. It's an execution engine.
Event-based or it's a batch.
Presto is a computational engine on top of big data. It's not a database.